If you've ever wanted to break into the AI and machine learning field, you are in the right place. We all know that hands-on experience is the best way to learn, and it's also what employers are really looking for. So today we are diving into 10 exciting real-world projects that will help you build the skills you need to stand out in this fast-growing field. But don't just take my word for it. So many individuals like Hari, Malay Kumar and Shrija landed their dream job in AI and machine learning through these hands-on projects. So if you're truly committed to securing your dream job in AI, you can join our exclusive free masterclass. So during this session, you'll gain hands-on experience with impactful AI projects. You'll be introduced to a proven 3-step framework and highlight the common mistakes that may be holding you back from landing a high-paying job. So you can register now for the masterclass by clicking the link in the description below. So let's get started. So the first project that we are talking about is AI Stylist personalized outfit recommendation with Amazon Bedrock, SageMaker and Stable Diffusion. So imagine having an AI stylist to help you choose outfits based on your preferences, upcoming events and the latest trends. That's what this AI Stylist project does, using Amazon SageMaker Studio, Amazon Bedrock and Stable Diffusion. So you simply provide the AI with some details about the occasion or your fashion preferences, and the system will suggest personalized outfits. It goes a step further by generating a visual representation of the outfit. So you can see exactly what it would look like on you. So the tools used in this project is Amazon SageMaker Studio, which is used to manage the AI workflow and test models. And then we have Amazon Bedrock, which helps generate the text prompts based on your input. And then there is Stable Diffusion, which creates high-quality images of the suggested outfits. And then Amazon S3, which stores all the data like your preferences, outfits, and images. So the steps involved is number 1, user input. You give AI a prompt like, what should I wear to a business meeting in New York? And the second step is data management. So the system stores relevant data in Amazon S3 to help it make informed decisions. And then there is text and image creation. So the Amazon Bedrock model creates a text-based description, and Stable Diffusion turns it into a visual representation of your outfit. And the fourth step is, of course, personalized outfit. So you get the perfect trendy outfit suggestion tailored to your style and needs. Now let's move on to the second project, which is Amazon Titan Image Generator, creating a visual ad for Octank dog food. So in this project, the goal is to create a visually striking advertisement for Octank dog food using Amazon Titan Image Generator V2. So the system takes a reference image like a picture of a dog and a descriptive text prompt, and then it generates a custom ad visual that fits the brand style. So this project shows how AI can be used for creating marketing visuals without needing a professional designer. So the tools used here is number 1, Amazon Bedrock, which provides access to the Titan Image Generator V2, which creates the visuals. And then we have Amazon SageMaker, which is used for managing the workflow and testing the system. Amazon S3, which stores the generated image for easy access and future use. So the steps involved in this project is number 1, input. You start by providing a reference image like a cute dog or the dog food itself, and a brief text prompt to describe what the ad should look like. And then we have image generation. So the Titan Image Generator V2 uses the input to create a stunning visual for the ad. And the third step is storage. So the generated visuals are stored in Amazon S3, making it easy to retrieve and use them for advertisement, product packaging, or social media campaigns. Our third project is resolving business challenges, evaluating AWS Bedrock models to optimize AI workflows. So in this project, the goal is to compare 2 AI models, Claude 2.1 and Claude 3 Haiku, to evaluate which one works best for business applications. So by using Amazon SageMaker Studio, the team tests these models by feeding them text prompts and analyzing their responses across metrics like execution speed, readability, and sentiment. This is a great way to determine which models will optimize business workflows and provide the best user experience. So the tools used are number 1, Amazon Bedrock, which gives access to the models Claude 2.1 and Claude 3 Haiku. Amazon SageMaker Studio is the environment where the team runs the tests and experiments. And then there is Amazon S3, which is used for securely storing generated data and outputs. And then we have Auto 3 SDK, which is used to automate the interactions with AWS services. So the steps involved is number 1, setup. The team sets up everything in SageMaker Studio, which acts as the hub for all the AI workflow experiments. Step 2 is model testing. Both Claude 2.1 and Claude 3 Haiku are tested by providing them with prompts. These models generate text responses based on the prompts. Third step is evaluation. So the responses are assessed on factors like how fast they were generated, the tone or sentiment of the text, readability, and even the word count. Fourth step is refinement. So based on the evaluation, the team refines the models to optimize them for real-world business use, making them more efficient and effective for specific tasks. Now let's move on to the fourth project, which is predicting university admission using Amazon SageMaker Canvas Autopilot. So this project demonstrates how Amazon SageMaker Canvas, especially Autopilot, can be used to predict university admissions based on historical data of applicants. So the goal is to create a machine learning model that helps university admissions teams quickly identify high potential candidates, streamlining the entire admission process. So using SageMaker Canvas, the team can automate predictions without needing to be machine learning experts, which makes the process more efficient and accurate. So the tools used are Amazon SageMaker Canvas, which is the tool that helps build the predictive model without needing any coding. And then we use Amazon S3, which is used to store the historical applicant data, which will be used to train the model. So the steps involved in this project is number 1, data upload. So first you upload a CSV file containing historical student data like GPA, test scores, and other relevant features. Second step is model creation. So using SageMaker Canvas, the system automatically selects the best algorithm for dataset, builds the machine learning model, and prepares it for predictions. The third step involved is prediction. So once the model is ready, it can generate predictions on whether future applicants might be accepted based on their application data. Predictions can be run in batch mode or in real time, depending on how you want to use the model. And the fourth step is deployment. So after the predictions are made, the model is deployed and it starts helping the admissions team prioritize high potential candidates. And the fifth step is cleanup and sharing. So finally, once the model is in place, users are shown how to clean up resources and share the results to make the process even more effective. Now let's move on to the fifth project, which is predicting customer churn using machine learning model. So in this project, AI Tech aims to predict customer churn for their music streaming service using Amazon SageMaker Studio and its suite of machine learning tools. So by building a predictive model, the company can identify customers who are at risk of leaving and take proactive measures to improve customer retention. So the project involves preparing the data, training a model using XGBoost, and deploying it to predict churn at scale. Amazon SageMaker makes it easy to manage the entire machine learning workflow, from data preprocessing to model deployment. So the tools used is number 1, of course, Amazon SageMaker Studio, which is a fully integrated development environment for managing the entire machine learning lifecycle. And then we use Amazon SageMaker Data Wrangler, which is used for data preprocessing and cleaning. And then we have Amazon S3, which stores datasets, results, and model outputs. And Amazon SageMaker Batch Transform, which is used to deploy the model and perform batch predictions. And then we use XGBoost, which is a powerful machine learning algorithm for classification tasks like churn prediction. The next tool we use is AWS SDK Boto 3, which automates and manages AWS tasks programmatically. Also, we use Jupyter Notebook, which provides an interactive interface for building and testing the model. So the steps involved in this project is number 1, data preparation. So the process starts with Amazon SageMaker Data Wrangler, which helps clean and preprocess the raw event level data like user activity. So this data is split into training, validation, and test sets, making sure the model gets quality data to learn from. The next step is model training using XGBoost. So Amazon SageMaker provides a pre-built implementation of XGBoost, a machine learning algorithm perfect for classification tasks like predicting customer churn. The model is trained on clean data and its accuracy is evaluated using the test set. The third step is hyperparameter tuning. To improve the model's performance, SageMaker's automatic model tuning, also known as hyperparameter tuning, is used. So this process adjusts the model's hyperparameters to get the best possible predictions, ensuring the churn predictions are as accurate as possible. The fourth step involved is model deployment. So once the model is trained and optimized, it's deployed using Amazon SageMaker Batch Transform. So this service allows the model to make predictions on large batches of data, so AI Tech can predict churn for all its users at once rather than one by one. And the fifth step is prediction and action. So the model's predictions can be used to identify at-risk customers, allowing the company to act quickly and improve retention strategies, whether through personalized offers, promotions, or targeted outreach. Now, the sixth project on our list is housing price prediction with Amazon SageMaker Autopilot. So in this project, ML World uses Amazon SageMaker Autopilot to predict California housing prices based on a variety of features such as location, house size, and neighborhood demographics. So the goal is to automate the machine learning process and make it accessible for both machine learning experts and non-technical users. SageMaker Autopilot handles the heavy lifting by automatically selecting the right algorithm, training the model, and fine-tuning it to deliver accurate predictions. The tools used are Amazon SageMaker Studio, which is the integrated environment for managing and executing the machine learning project. And then we have the Amazon SageMaker Autopilot, which automates model creation, training, and tuning. Then we use Amazon S3, which stores data sets and model artifacts securely. Amazon SageMaker Batch Transform, which helps run predictions on large data sets in batch mode. So the steps involved in this project is number one, data preparation. The California housing data set, which includes features like house size, location, and median age of house, is loaded into Amazon S3. SageMaker Autopilot automatically handles data preprocessing and feature engineering, including cleaning the data and encoding features for use in the model. The second step is model training. So SageMaker Autopilot evaluates multiple machine learning algorithms and hyperparameters to identify the best performing model for predicting housing prices. So this automated process saves time and ensures the best model is selected without requiring manual intervention. The third step is model evaluation. So once the model is trained, its performance is tested using a test dataset. So SageMaker Autopilot provides accuracy metrics and error metrics, giving the team insight into how well the model can predict housing prices based on the features. And the fourth step is batch prediction. So after training and evaluation, the model is used to make large-scale predictions using Amazon SageMaker Batch Transform. So this allows the team to predict housing prices for a large number of properties without needing to deploy a real-time model endpoint. Now, before we dive into the seventh project, I want to remind you to join our free masterclass. So in this session, you will gain hands-on experience with these projects, learn the proven 3-step framework, and discover how 45,000 individuals achieved success using these strategies and how you can too. So feel free to register through the link in the description below. So now let's move on to the seventh project, which is real-time stock data processing. So in this project, we are focusing on processing real-time stock market data using Amazon Kinesis, a powerful tool for handling streaming data. The system uses Amazon Kinesis Producer Library, KPL, and Kinesis Consumer Library, KCL, to ingest and process live stock data. So this data is analyzed to generate valuable insights like moving averages, price anomalies, and other trading metrics. The processed data is then stored in Amazon S3 for persistence and further analysis. From there, it's fed into Amazon SageMaker to build predictive models and provide real-time trading insights, alerts, and recommendations. So the tools used in this project is number one, Amazon Kinesis data streams, so for real-time data ingestion and streaming. Amazon S3 for storing processed data securely and integrating with other AWS services. Amazon SageMaker Studio for deploying the producer-consumer system and conducting predictive modeling. And then there is Kinesis Producer Library, KPL, which is used to stream stock data into Kinesis data streams. And then we have Kinesis Consumer Library, which is used to process and transform the data as it streams in. We'll also be using Jupyter Notebook in SageMaker Studio, which is for managing and automating the machine learning workflows. So the steps involved are, the first step, real-time data ingestion. So KPL is used to stream live stock market data into Kinesis data streams. This ensures that the data is efficiently batched and transferred in real time, allowing the system to work with fresh up-to-the-minute information. The second step is data processing with KCL. So the data is processed in real time using Kinesis Consumer Library. This part of the system calculates key metrics like moving averages, detects price anomalies, and transforms the raw data into actionable insights. The third step involved is data storage and integration. So after processing, the data is stored in Amazon S3, allowing for persistence and easy access for further analysis. If needed, the data can also be loaded into Amazon Redshift for high-performance querying and deeper analytics. Step 4 involves model deployment for predictions. So the next step involves using Amazon SageMaker to build and deploy models for predictive insights. So these models can analyze trends, forecast future stock movements, and provide trading recommendations. So this is key for real-time decision making and automated trading strategies. Moving to the 8th project, we have credit card fraud detection using Amazon SageMaker. So this project focuses on building a real-time fraud detection system for credit card transactions using an imbalanced dataset. So the goal is to secure financial transactions by detecting fraudulent activity as it happens. So the tools used in this project is Amazon SageMaker, which is used for data pre-processing, model training, and deployment. Then we have AWS CloudFormation, which automates the setup of infrastructure for the project. Amazon S3, which stores datasets, model artifacts, and results. XGBoost algorithm, a powerful machine learning algorithm for binary classification, tasks like fraud detection. And then we have SageMaker hyperparameter tuning used to optimize the performance of the XGBoost model. And also we'll be using AWS Python SDK, which helps manage AWS resources programmatically for automation. So the steps involved in this project is number 1, data pre-processing. The raw credit card transaction data, which is often imbalanced with fraud being a rare event, is pre-processed. So this step involves cleaning the data and transforming it into a format suitable for machine learning. Amazon SageMaker is used for these pre-processing tasks, ensuring the data is ready for model training. The second step is model training. So using Amazon SageMaker, the XGBoost algorithm is trained on the pre-processed data. XGBoost is ideal for binary classification tasks like fraud detection. So the model learns to distinguish between legitimate and fraudulent transactions by analyzing patterns in the data. Hyperparameter tuning. So to improve the performance of the XGBoost model, SageMaker hyperparameter tuning is used. This process optimizes key parameters of the model to increase accuracy and minimize errors, ensuring the best possible performance. Now the fourth step is model deployment. So after training and tuning the model, it is deployed using Amazon SageMaker, making it available for real-time predictions. So as new transactions come in, the model can quickly predict whether the transaction is fraudulent or not, providing immediate insights to financial institutions. And the fifth step is real-time predictions and monitoring. So once deployed, the model continuously processes incoming transaction data in real time through AWS Lambda and Amazon Kinesis. So predictions are stored in Amazon S3 for easy access, and visualizations or alerts can be triggered based on the fraud prediction results. Optionally, Amazon QuickSight can be used for advanced visualization of the results to track fraud trends. Now the ninth project on our list is image semantic segmentation using AWS SageMaker. So in this project, an autonomous vehicle company uses AWS SageMaker to implement image semantic segmentation, which is crucial for tasks like identifying road elements such as lanes, pedestrians, and vehicles in real time. So this project is focused on accurately classifying each pixel in an image to improve the safety and navigation of the vehicle, allowing it to understand the environment and make decisions based on visual input. So the tools used in this project is Amazon SageMaker for training the model, deploying it, and making predictions. Amazon S3, which stores and manages the image dataset used for training the model. Then we have SageMaker Studio, which is an integrated development environment for machine learning workflows, which simplifies model building, training, and deployment. Semantic segmentation model, which is used for pixel-level classification of images to distinguish between different road elements. And then we have AWS Python SDK, which is used to automate and manage resources and workflows programmatically. So the steps involved in this project is number 1, data collection and preparation. So the process begins with downloading and extracting image data from an online image directory. So these images represent different road elements that need to be segmented, such as lanes, vehicles, and pedestrians. The second step is data upload to Amazon S3. So after the data is prepared, it is uploaded to Amazon S3 to store and manage the image dataset. So S3 ensures the data is easily accessible for the training process. Third step, model training. So the next step involves training the semantic segmentation model using AWS SageMaker. So this model classifies each pixel in the image, identifying different objects that are important for autonomous vehicles navigation. Now the fourth step is model deployment. So once the model is trained, it is deployed using SageMaker and predictions are made using a notebook instance. So the deployed model can now be used for real-time image segmentation, enabling the vehicle to detect road elements in its environment and make better navigation decisions. Now the fifth step involved is prediction and evaluation. So the model can be used to predict and classify images that the autonomous vehicle's cameras capture. providing real-time feedback on what's happening around the vehicle. So this prediction is critical for tasks like lane detection, pedestrian identification, and vehicle detection. And finally, we are moving on to our 10th project, which is building an AI agent using AWS Bedrock. So this project focuses on creating an AI agent using Amazon Bedrock, which helps automate tasks such as querying AWS documentation, generating infrastructure as code (IAC), estimating infrastructure costs, and explaining AWS solutions. The tools used in this project is Amazon SageMaker, which is for training models and integrating them into workflow. Then we use Amazon Bedrock for deploying and managing AI agents using foundation models like Claude 3, AWS Lambda to handle the execution of different tasks and integrate external systems. We use Amazon S3 for storing documents, model artifacts, and infrastructure data. InfraCost, which is a third-party tool for estimating the cost of infrastructure, and AWS Python SDK, which is used to automate the management of AWS resources. Now, the steps involved is number 1, set up the environment. So you have to begin by cloning the project repository and installing the necessary dependencies to build the agent. So this includes tools like Python and Docker. Next is QA chatbot. So the first tool in this agent is a QA chatbot that utilizes a knowledge base. So this knowledge base is populated with AWS white papers and architecture diagrams stored in an S3 bucket. So the agent uses Amazon Bedrock's retrieval augmented generation RAG system to answer queries based on these documents. So it improves upon the standard responses by incorporating specific up-to-date AWS documentation. Now the next step is to explain diagrams and generate IAC. So the next tool used is powered by Claude 3, which is a multi-model LLM capable of analyzing architecture diagrams. So the agent can explain the components of these diagrams and generate infrastructure as a code. So by uploading an architecture diagram, Claude 3 helps the agent understand the system design and generate corresponding Terraform code for deployment. Next is estimating costs using InfraCost. So the third tool integrates InfraCost, a cost estimation tool that calculates the monthly cost of running infrastructure on AWS. So after generating the IAC, the agent estimates the cost to run the infrastructure based on the generated code. It then returns a breakdown of the costs for each AWS service. The next step is integration of tools. So these tools are integrated into the agent and the interaction with each tool is managed through AWS Lambda. The agent can invoke different APIs depending on the task. Example, generating IAC, answering queries, estimating costs, etc. So the agent operates based on user requests such as generate Terraform code for a standard e-commerce application or estimate the cost of running a solution on AWS. Now the sixth step is deploy and test the agent. So once the agent is built, it's deployed as a Lambda function. Permissions are configured for Amazon Bedrock and S3 to access and interact with necessary resources. Finally, the agent is tested by providing prompts like generate Terraform code for a Magento e-commerce application and evaluating its responses. And that's a wrap for today's video. I hope you are feeling inspired and ready to jump into these real-world AI and machine learning projects. We're also planning to create a detailed step-by-step full project guide, so let us know which project you'd like us to cover in this channel by sharing your thoughts in the comment section. So as mentioned earlier, if you're eager to work on these projects and gain hands-on experience that can help you secure a high-paying job, make sure to join our free masterclass. Also, in addition to hands-on projects, you'll receive a proven 3-step framework and a comprehensive roadmap. We'll also point out the common mistakes that might be holding you back and show you how to avoid them. So you can register now by clicking the link in the description below. And also, if you're struggling to land a job in AI, data, or cloud, be sure to watch this video here. We have shared valuable insights on how to secure a job in these fields by reverse engineering the process, optimizing your resume and LinkedIn profiles, how to use AI tools for job applications, and I've provided interview preparation tips also. So definitely check out the video. Thanks for watching.